All right, we're going to start chapter 8 now. Chapter 8 is mixtures, solution concentrations, and diffusions. So we're kind of done with the organic in the sense of the compounds, naming them, whatever. We're going to move on to some mixtures and stuff that you can make with them. And we're going to talk a little bit in this unit. We're going to talk about a little bit of the reactions with organic, okay? All right, so mixtures is a combination. And you've probably heard of mixtures before. A mixture is two or more elements or compounds that are mixed in any proportion, okay? It's not a chemical compound. A chemical compound has to be in a certain proportion, like water has to be 2 hydrogen to 1 oxygen. In a mixture, you can mix whatever amounts you want, and then there's 2 parts. Whatever dissolves is called the solute. Whatever does the dissolving is called the solvent, okay? You can tell it's a mixture a couple different ways. First of all, you can separate them. In a chemical compound, you have to go through a chemical reaction to separate them, and they don't always do, excuse me, don't always do that. But in a mixture, you can separate it by sight. If you have a mixture of marbles and sand, you can just pull the marbles out. You can use filtration, like pour it through a filter paper. You can boil off, if it's water, you can boil off the water, and you'll get your solid back. So there's all kinds of ways, but they're just physical means of separating. Okay. And when you look at mixtures, you have 2 types. You have a not so well mixed mixture. It's called heterogeneous, which means you can see like layers, you can see parts in it. And then you have a homogeneous mixture. And remember from chemistry when you've taken before, a homogeneous mixture is a solution. A solution is a well mixed mixture, and that's what homogeneous. You can say homogeneous or homogeneous. I've heard it both ways. Okay? So in a homogeneous or homogeneous mixtures, you can't see parts. Everything is evenly distributed, okay? And in a heterogeneous, you can see parts. You can see layers, you can see actual particles, things like that. So that's your 2 types of mixtures, heterogeneous and homogeneous or homogeneous. And now we're going to talk about they have different parts as well. Okay, if you want to separate them, like if you take all matter, okay, and then we have pure substances and we have mixtures. This part we're not talking about because this is chemical. Okay, a pure substance, it means it's always the same. The amounts are always the same. Elements, compounds. Okay, when you're talking about, this is what we're going to be talking about this chapter, mixtures. A mixture is either well mixed, so it could be a solution or what they call a colloid, or it can be heterogeneous. Heterogeneous means it's not mixed up very well, and that's a suspension. And a suspension, particles settle out. Okay? So when we're talking about mixtures, one of the ones you probably haven't heard a lot about is called a colloid. What happens with a colloid, and these can be either homogeneous or heterogeneous. Okay? The thing with a colloid is you have particles that are medium in size, and what happens is they kind of stay in suspension, but so you might not see them, but they do things. You know, there's certain characteristics of the colloid because of those particles, of the size of the particles, okay? The minor component or components are called colloids. And the best way I can describe it is because you have a colloid and the particles are larger, they actually reflect light. An example of a colloid is fog. Have you guys ever been driving in fog? You turn your highs on and it just like, oh, blasted, you turn them right off again because it's too much reflection. In the fog, you have particles that are big enough to reflect the light, and they do it right back to your eyeball, so you shut it off, okay? Other examples of colloids would be like gelatin. You know, it's not clear. I mean, it's a little fuzzy when you look through it, or there's aerosols. There's all kinds of colloids. So they're in between a well-mixed mixture like a solution and then a suspension where you have big particles that settle out, okay? Here's the range. So under this range, less than 1 nanometer is your solution particles. Above this range, 1 micrometer is your suspension. So colloids are right in the middle, okay? They dissolve, but they kind of stay in suspension. And even though you can't always see them, they're there because they reflect light, okay? Colloids can be opaque, which means you can't see them at all, or you look through them and they look a little fuzzy, okay? They're found in all 3 stages. If you have an aerosol has particles like solid or liquid colloids. Fog, like I said, is a good example of a colloid. Paints, believe it or not, are colloids. There's emulsions like mayonnaise. Okay, you have particles in there, and gelatin. And honestly, when I do examples of colloids, I tend to use gelatin because you can kind of see through, but it's a little fuzzy when you look through it, and it reflects light. Okay, so the big thing with colloids is they're in between a solution and a suspension, and their particles are big enough to reflect light. You might not necessarily see them, but they do stay in suspension. They don't settle out. Okay, a suspension is really easy. You have large particles and they eventually settle out. If you take a jar and put mud in it and some water and you shake it up, for a minute it looks like it's all mixed up, and then the mud will settle to the bottom. Or those little snow globes, you know how you shake them and then the snow falls down and eventually it's all in the bottom and you got to shake it again. Those little snowflakes, fake snowflakes, though, that solution there is a suspension because those particles are going to settle out. Okay, they have medications sometimes you have to take that are suspension. For some people that have troubles with pills, and the big thing with if you have a suspension, before you give it to somebody, you got to shake it up really good. Give it to them on their spoon, give it to them, and then as it sits, it'll separate again. Okay, so that's a suspension, and sometimes medicines are suspensions. But the thing with them is before you give it to somebody, you've got to really shake it up because otherwise they're not going to get the medication. One of the ways that they can separate out stuff in suspension is a centrifuge. You know, those big spinny things. You put the tubes around and it spins it around. And what will happen is you'll get the particles that will settle out eventually, but this speeds up the process. In the bottom, they collect them, and usually it's called a pellet. Okay, they're little tubes. There's big centrifuges, huge ones, and little tiny ones. In the lab, we have little tiny ones where you put little microtubes in there, but you'll see huge ones in labs. And I mean, I saw one at Minot State that held like beakers. It was huge, and when it spun, they said if it got off kilter, it would like go through a cement wall. I don't know if I'd want to play with something like that. That would be a little scary. Okay, so the portion that doesn't settle out, the liquid part, that's called the supernatant, and I'm sorry you can't see it. It's supernatant. Okay, supernatant, and then you have a pellet. So the centrifuge, by spinning it, separates it for you. Okay, now solution. Okay, that's what we talk about mostly in chemistry. This is a mixture. Okay, it is not a chemical compound. All right, it usually takes a chemical compound mixed with another chemical compound. Okay, but you have very small molecules, atoms, or ions, depending on what you're doing. Their diameter, like I said, they're less than 1 nanometer. You can't see them. Okay, the component present in the greatest amount is called the solvent. Most common solvent is water. Usually the solvent you can still see. The component, lesser amount, the one that usually disappears or dissolves, is called the solute. So if I was making a saltwater solution, salt would be the solute because it would disappear, and then the solvent would be water. And again, water is the most common solvent. Whenever you're making a solution, if you use, usually if you have a solid and a liquid, you're going to use water. Okay, they even call water the universal solvent because you use it more than anything else. Okay. And again, we talked about this before. If water is the solvent in an equation, you'll see AQ. AQ just means it was dissolved in water. Okay, so sometimes when we do chemical reactions, if I just have the powder, it won't work it'll take forever. So I'll take that solute part and I'll dissolve it in water, and then it'll be an aqueous solution, and then the reaction will happen. Okay, there's also a mixture of gases. Now, when we talk about mixtures, it's not just a solid and a liquid. It can be 2 liquids. It can be 2 gases. The most common and most important mixture of gases would be air. Okay, some people for some reason think air is a compound. It is not. Air is a mixture. You have nitrogen, which is the most common. It's like almost 80%, not quite 80%. Then you have oxygen. Those two together make up about 98.9% of air. And then you have water vapor, carbon dioxide, some of the neon, some of the noble gases are mixed in there, argon, and so on. But they make up a very small part of it. But it is a mixture. How do I know it's a mixture? If the air outside, if it can be different in different places, it is not a compound. And air outside and air inside is different because of filters in the air and all that other stuff, or more water vapor outside than inside, and so on. So because air's composition isn't always the same, I know it's not a compound, it's a mixture. Okay, solutions, again, we have liquid, solute, solvent. The most common is where you have a liquid and a solid. That's the most common. But you can have a liquid, solute, and liquid solvent. That's very common as well. You can have gas solutes. If you have if you like to drink pop, you have a liquid there. Actually, you have two. First you have your sugar dissolved in water. That's your first one. That's a solid and a liquid. And then you add gas to it. So now you're taking a gas and dissolving it in a liquid. That's your carbonation. So actually there's two different things there. But you can have gas solutions dissolved in liquids. You can have solid and solid. One of the most common things that they use with metals are called alloys. Maybe you guys have heard of them before. Like your jewelry. 24 karat gold is pure gold. If you had a ring made out of pure gold, besides the fact that it costs more, it would not last long because gold is soft. So what they do with the gold is they add other things to it to toughen it up. So that's why you'll see if you have a ring, it'll say 14 karat gold or 18 karat gold because it has other things in it. It makes a mixture. One of the most commonly used mixtures is stainless steel. Steel is not an element. Steel is a mixture of chromium and iron, and sometimes carbon too, graphite. Okay, so an alloy is a mixture of solids. Okay, so mixtures, what that point of that whole thing was, mixtures isn't just a solid dissolved in a liquid. You have all kinds of them. Okay, when you're looking at solutions, the solubility, how much you can dissolve, depends on some things. One of them is the polarity of the solute and solvent. And when I talk about that, there's bonds, there's ionic bonds, there's covalent bonds, and of covalent bonds, where they're sharing electrons, the covalent bonds, there's polar ones and there's nonpolar. Polar means they're not sharing them equally. Nonpolar means they're sharing them equally. Well, if you have a polar substance and you put another polar substance, chances are they'll dissolve each other. They have a saying, it's called likes dissolve likes. So if there's similar bonding, they will dissolve each other. Okay? When you get grease on your clothes, if you put water on it, it won't take it out. Grease is an organic compound. It's nonpolar. So nonpolar and polar, water, they don't mix. That's why oil and water don't mix, because their bonding is different. So if you put a polar with a nonpolar, they're not going to mix. If you put two polars together, they will mix. Two nonpolars, they will mix. And a trick that I learned, if you get grease on your shirt, if you go buy butane, like the Zippo lighter fluid, which is butane, it's an organic compound, put it on your grease right away and wash it, you'll get rid of that grease. Okay. Then they have something called the hydrophobic effect, and that's what happens when you have two different bonding. Hydrophobic means it doesn't like water. Okay? Hydro, water, phobic, it's afraid of it. Okay? So again, when you have a polar and a nonpolar, what will happen is the water won't mix with that nonpolar. They have that effect where they push it away, and so they avoid the clusters of the nonpolar. They'll join together and form a big cluster, and they won't let the polar in. And that's again why nonpolar and polar do not mix. Okay? So compounds with polar and nonpolar, they won't mix together. Okay? If you put a polar with an ionic, they'll mix. If you put a polar with a polar, they'll mix. But if you put a nonpolar and polar, they won't mix. And that's the likes dissolve likes thing. Okay? And this is an example where you can see it. Okay? We have this. Here's, this is salt, which is an ionic compound when you add water to it. The water will get in between there and it's attracted, the positives to the negatives. You can see the sodium is positive and the hydrogen part of water is negative. So they're attracted to each other. And here you have your negative chlorine and the hydrogen is positive. So they're attracted to each other, they'll break each other apart, and that works. Okay? So these are called ion dipole interactions. Okay? I can only get through maybe one more slide. Okay. When you're looking at a solution, okay, again, if they dissolve, it depends on that polarity. They'll dissolve up to a certain point and then they won't dissolve anymore. Okay. So not all ionic compounds are soluble. Here you can look, this one. Oh, and the other thing with solubility, you have a limit amount. Okay. Here it dissolved at first, but then you added too much and then it settled out of the bottom. Okay. So you have a limited amount. And I'm running out of time, so I'll pick this up on the next part.